last tutorial, we looked at the native SegWit. So right now we'll be looking at Taproot. So first things first, I'll generate a new address. I'll just get a new address. Let me get a new address, and this time I'll get a Taproot one, a Taproot address. So no label, Taproot. So this will be address 1, and I'll do address 2. So these are 2 addresses. Okay, so I'll make the first transaction. First of all, I'll transfer the cash. Let me just look at the balance. Get balance. Okay, so now I'll send to this Taproot address. Okay, so, and I'll be utilizing this balance over here. Yeah, so this is my first Taproot transaction, determining the output script. And then I'll again get the balance and then do my second transaction that will be consuming the output produced by this. Yeah, so this is my second transaction. Yeah, so yeah, sending to address 2. Okay, so now here is the current transaction. So SegWit is a bit different, yeah, because of both the output and the input scripts, as we will see shortly. So this one should be consuming this one, so I'll just get the transaction. Let me get this first transaction. Yeah, so this is the current transaction. So as you can see, there's an input pointing to this previous transaction. So now we'll be going to this previous transaction to determine the output script for each. Yeah, so now we'll be checking its output scripts. So this is the output script. So this just means that it is SegWit version 1. Yeah, and something that is different is that it has a public key. Yeah, so everything in SegWit is committed to a public key. So as you can see, let us just check the size of the public key. Okay, so as you can see, the public key is 32 bytes. So I just created the tutorial to show you the difference between the taproot and the others. So with the taproot, uh, there's no part like positive or negative. So there's the it is less 1 byte as compared to the other ones that we've seen so far. When you see at the other ones, you can see that it commits to something else, but their public key can either start with a 0 or a 2. So it means that there's an extra byte with them, as you can see from here. So when we calculate this one, we will see 66 characters, hexadecimal characters, meaning that they are 33 bytes. So the taproot is less by 1 byte because it always takes the positive side. So there's no the prefix to determine either y is positive or y is negative. So the other difference between taproot and the other ones is that this the witness is composed of the Schnorr's signature, as we will see. So this is our previous transaction. So when we look at the current transaction, we'll only see one thing on the witness. This is our uh, this is our previous transaction. Let us look at the current one. Okay, so this is our current transaction. So when we look at the input of the current transaction, we'll only see this is the input. Let me look at the input. We will only see only one signature. So there's no public key, there's only one signature. And the other difference between taproot and the other ones is that this is a Schnorr's signature. And Schnorr's signatures have how many bytes? Let me just look at the difference between them and the other ones. So yeah, they are 64 bytes, meaning that they are 7 bytes short. They are shorter than the other ones. When we look at the other ones, we can observe that they are 71 bytes. They are 71 bytes. Okay, so I'm looking at the length. Yeah, so 142 characters, meaning that they are 171 bytes, meaning that the two main differences between taproot and the other ones is that the first difference, the public key is 32 bytes as compared to the 33 bytes of the other ones. The second difference is the length of the Schnorr signature is 64 bytes. Is 32 bytes. Yeah, it's 64 bytes as compared to the 71 bytes of the other ones. Yeah, and as you can see, there's no opcode to direct the execution. So yeah, that is those are the main differences, yeah, between the taproot and the other ones. Yeah, so we can only see that the input is composed of a single no signature, and the output is composed of an X only public key, so there's no prefix to determine if the Y is on the positive or the negative side. Yeah, so that's it.